you're okay with that. The way we move these things around. Undo add cosine squared by subtracting cosine squared on both sides. On the left, I'm left with sine squared. On the right, I'm left with 1 minus cosine squared. Good? Really? No issue. It's a lot of conversation in the last class. Okay, I will hand back the quizzes that you took last week after I catch the last 2 people. If you missed the quiz last week, it was on trig inverse. Did you take it? I did?
Yeah.
Yeah? So there's 2 people in here, I talked to 1. 2 of you've missed it. If you don't take it today, we'll do the retake and that's it. There's an quiz Thursday. Let me show you. So today we need to review trig identities. We're going to get to more of them. And we're going to apply those identities to do some stuff. Homework tonight is on Delta Math. And again, I'm going to hand up on Tuesday your quizzes. You need to get me quiz corrections by Thursday. Because Thursday, there's a quiz that will have some trig inverse, and a piece of this quiz can replace a piece of your other quiz. If you do not turn in the corrections, I can't tell how you did on that piece. So then there will be no replacement option if you don't turn them in. Okay. And you guys tried this. And I should make this say solving for tangent squared or cotangent squared. All right, so Nor, what can I do to this first equation to solve for 1?
Move tan to the other side. It's gonna be 1 equal secant, or you could also say 1 over cosine squared minus tan squared.
Okay. I know what you meant, and you said one thing wrong. Like.
For tan, you could also say sine over.
So, what would 1 equals, what was it again?
1 over cosine squared.
Okay, I'm gonna leave it as secant squared.
Okay. Minus minus tan squared.
Okay. Last time you didn't say the squared. I think you wrote it down, but you didn't say it. So, last week, all of these things, this is cosine, this is sine, the radius on the unit circle is 1. Pythagorean theorem is a squared plus b squared equals hypotenuse squared. So please remember they're all squares. Luca, what about this one? How do I get 1 all alone? Cosecant squared minus cotangent squared. All right, just want to make sure that you guys know that they are squared because there's one that's gonna mess you up in a minute. Okay, Isla, yours is the next paper up here. How do I take that first equation and solve for whichever one of these is in it? No, I just want, what does tangent squared equals what?
Tan equals secant squared minus 1.
Okay, and tangent squared equals secant squared minus 1. Oliver, here, solving for cotangent squared. What is cotangent squared?
Cosecant minus 1.
No,
Cosecant squared.
thank you. Like, okay, so don't be lazy with the squares. I realize, I think you're writing them, but you're not saying them. There were some homework problems out of the textbook. Do you guys have questions on any of those? Yes. Yeah,
I couldn't do number 11.
number 11. Ah, that one wasn't assigned. Alana? Ahmed? 25? Mohammed, what's the identity that has this in it? What's the rest of it? Check your notes, it was written down today. Irina, he's in your group, can you help him out?
Cos squared dl 1.
Okay. Bummer, I don't need either of those. Bella, what's one of them, like if I divided everything by sine squared or everything by cosine squared, what's another one I could've gotten? Okay. If I divide everybody by cosine squared, what is sine squared divided by cosine squared? Tangent,
Squared.
thank you. And what is cosine squared divided by cosine squared?
Secant.
Okay, what is 5 divided by 5?
Oh, 1.
What is cosine squared divided by cosine squared?
1.
There you go. And now this side, 1 divided by cosine squared, you're right, is secant squared. Okay, so there's something useful here. Alana, what's the one, now if I divided everybody by sine squared? Sine squared divided by sine squared is
1.
cosine squared divided by sine squared.
Cotangent.
Co-
Squared.
Thank you.
And then
1 over sine squared is
cosecant.
squared.
Yeah, squared.
Okay, so, kinda need to know those. Danny, what do I have to do to this equation to get rid of the parentheses in that first set of parentheses? I need to distribute the number that is out front. What number is written out front?
1.
It's not written, but it's implied to be a 1. So when I multiply everybody by 1, what happens?
You just.
Absolutely nothing, I can just make, okay, yeah, all right. He's looking at me like, duh, that's stupid. Just making sure we know that that's a math thing. Okay, trickier though. Sherry, what number is written in front of these parentheses?
1. Negative.
-1. So how do I make those parentheses go away? distribute the negative. Okay, Valentina, looking at this one that has secant squared on it, what is secant squared minus tangent squared? 1. So secant squared minus tangent squared is 1. Ahmed, oh, sorry, what? Here, subtract tangent squared to the other side. Yeah? So Ahmed, looking at the one in red, what is cosecant squared minus cotangent squared?
-1,
Why is it -1?
because I moved the 1 over.
Cosecant squared minus cotangent squared. Is that a positive one that's still over there or a negative one? So positive 1 equals cosecant squared minus cotangent squared. This is a positive 1, and 1 plus 1 is 2. Other issues with any of these guys? Yes? 15. Go on.
For a William, or is this a really bad one?
He's ready to go. He's like, let's.
I'll only need him for just 2 minutes.
Okay, 15. It's got a cubed in there. I so totally don't dig cubes. What can I need it to be a squared, because that's what I know stuff about. Is there something, Isaac, do you see, is there something I can do to number 15 to get something squared?
Take out cosine.
If I factor out cosine, great idea. Mohammed, when I factor out cosine, I'm really dividing all of these guys by cosine. So what is cosine divided by cosine? Is it 1 or is it 0? It's a 1. When I do cosine to the third divided by cosine to the first, what does that become?
2.
Cosine squared. Okay, cool. Eleanor, cosine squared plus sine squared equals 1. What is 1 minus cosine squared x? Sine squared? Here's the answer I get. Questions? Okay. We need to look at a stinker of a problem. I don't believe I assigned this one, but it's on that page. This one, lots of steps, major pain. So if you don't have it written down, write it down. Is 1 plus tangent equal to secant? Okay, I heard a yes. And I disagree. The identity that we know, as I kept saying, is all these things squared. So there's one of those triangle patterns, 3, 4, 5 triangle, 3 squared plus 4 squared, 9 5. Yes, right? So here's my question. Can I just do the square root of everybody? Isn't 3 plus 4 equal to 5? What is 3 plus 4? 7. So does 3 plus 4 equal 5? So this is a bunch of hoo-ha. You cannot do that. So 1 plus tangent, it would be so nice if I could just say that, but it's not true. It's got to be a squared, so that ain't gonna work. So I can't swap anything out. Can I square the whole thing? I can only, like, can I just, cause I really would like it to happen, can I just triple the balance in my bank account by just, no, cause I don't have two sides of the equal sign. So I need to do something different to try and prove this one. You got a suggestion?
So we can write like tangent equal sine or cosine, so 1 plus sine or cosine.
Okay, so he says, you know, I'm not sure what to go from here, but he suggests turning everything into sine and cosine. Great idea. If you're stuck, this is a strategy. By the way, you will get stuck in these trig simplifying things a lot. So, I don't know where we're going with it, but a good idea. And normally we're gonna have to like flatten it out. Emma, do you have a suggestion or you just fixing it?
Oh, I have a suggestion.
Okay.
Can you just like divide by like cotangent?
Dividing everybody by cotangent. That just turns it upside down. If I divide everybody by cotangent, maybe we'll start that way, or, but from what we have in the red, we'll come back to that, maybe that works.
Do like keep change flip on the two things?
I'm not understanding what, I mean, maybe?
Like when you're dividing to, you do like a sine over cosine, and then you multiply it by.
By the flip?
Yeah.
But I don't have this as a single fraction. I need it as a single fraction, yeah.
You can just add that, like cosine over cosine plus sine over cosine, so.
Okay.
Cosine plus sine over
So,
cosine.
yes, that's valid, and I'm gonna show you how I do this. He's saying, do common denominator in the top, common denominator on the bottom, and I'm gonna show you a different method, but we're gonna get in the same place. I don't like fractions and fractions. This guy's denominator, if I multiply by cosine, that guy's denominator goes away. I can't just multiply the top, I gotta multiply the bottom as well. Cause I've gotta be multiplying by 1, otherwise I'm doubling, tripling, quadrupling my bank account, which could use that right now, but. And looking down here, to get rid of sine, I'm gonna have to multiply by sine. So Luca, we're gonna get to the same place, just, it looks different. What is 1 times stuff? Stuff. Okay, so 1 times stuff, I get cosine x, sine x. Senna, this one. I'm doing sine over cosine times cosine sine. This cosine on the bottom, what does it have, what does it do with this guy cosine up top? Eliza's saying it does the John Travolta cancel. Do you agree? So I'm left with sine times sine, which Sophie is what? Sine squared. And that was a plus, so it's a plus. Okay. Kira, in the denominator, 1 times stuff, still stuff. Kylie? Cosine divided by sine times cosine times sine, what is that? That sign on the top is divided by that one, so it's cosine squared. Okay. So last class. Am I allowed to cancel cosine sine over cosine sine?
Yes. Oops, just turn them off.
Does 3 plus 6 divided by 3 equal 6? Why not? That would be so much more convenient. Emma?
Because can't you now do it's like add and subtract?
Yeah, you gotta do the add first. And with variables, it's so tempting, especially when it's like, oh, look, they're so nicely lined up with each other, but they're being added in the top and added in the bottom, they don't cancel. So I can't do that. All right. Well, shoot. Must be something we can do. Yeah.
So, we can write like sine times cosine plus sine over cosine times sine plus cosine, so.
Okay, wait,
we have sine
wait,
cosine.
you're too much. Up top, I have two terms. Is there a sign on both of them? So Emery, when I factor sine out of the first term, what do I left? What am I left?
Would just be cosine plus sine.
Okay, so he did both. He said that first one, when you factor sine out, it's left, cosine's still there. There was sine times sine here, he took one of them out and he says that's plus sine. Okay, looks a little gross. But that's all right, we're cool with that. In the bottom, what if I factor cosine out of both of them? Aaron, what's left in the bottom if I take cosine out of that first term?
If you take cosine out, it'd be sine plus cosine.
All right. Now here's the question. They don't look the same. But is 7 plus 1 the same thing as 1 plus 7? So is cosine plus sine exactly the same thing as sine plus cosine? And was the big parentheses crap up top multiplied? The big parentheses crap on the bottom is multiplied, so can I cancel them? You promise? Yes, they do. And I'm left with sine over cosine, which, William, what does sine over cosine, what does that equal? So that is long. There's, someone in third period was like, isn't there a faster way to do that? There are alternate long ways to do that. I mean, this was only 3 steps, but it was a lot of thinking. Again, math teachers, we love this because it's like, they're puzzles. Y'all, not so into the puzzles. But one strategy, Luca just said, his start was turn them into sine and cosine and smush things around. Flatten the fractions. Factor some stuff. All of your favorite things. Fractions and factoring. Woo, lines and tires, bears. Emma, yeah.
If you were to like divide everything by tangent, it would equal cotangent, so can you just do the same thing?
Okay, so, can I erase all this? We're now gonna try the oh, yeah, guys?
I'm kinda confused of how we got cosine sine, like the
From
second step.
These guys?
Yeah,
Like where this came from?
the first part of it.
Do you see why I wanted to multiply by cosine and sine on the top and the bottom? Because I want to make this denominator go away. So the stuff that's in red, it was 1 plus sine over cosine over 1 plus cosine over sine. Distributing this to everybody, it's technically over 1. So cosine x sine x is cosine x sine x. This business, the cosine's canceled and it's sine times sine, which is sine squared. This guy down here, cosine sine times 1 is cosine sine. This guy, sine, canceled with sine, so I'm left with cosine squared.
Alright, very good.
Yep.
Thank you.
Alright, can I clear now so we can try Emma's way? So you're saying divide everybody by tangent? Is that right? Okay, I mean, dividing by tangent is multiplying by cotangent, so are you okay if I write it like that? So cotangent times 1, cotangent times tangent? And then if I multiply down here, okay. It's yucky, but it is cleaner. Are you guys okay with that first step, or I completely confuse you? I did combine this one. Tangent times its reciprocal, tangent times cotangent. Becomes 1. Look at the denominator. Is there something I can do? Like, maybe I shouldn't have done this in the first place. Maybe I should have just left it as cotangent x. Oliver, do you see anything in there? Looking at it right now?
The same at the top.
Cotangent plus 1 is the same as 1 plus cotangent. So that was prettier. Is that what you meant, or is you like, yeah, that's what
That's
I'm.
what I did.
Okay. Yeah.
Wait, what if you just multiply the top by 1 plus cotangent x? Would that do the same thing? Just to get rid of the denominator? Or is that?
I can't, I gotta multiply by 1, so it's gotta be
Okay.
1 plus cotangent over 1 plus cotangent, which is not gonna be nice. And I think this is what, what you said in the first place. I thought you said, you might have said multiply by tangent on the top and the bottom, or divide by tangent, I don't remember which way, but,
I said the tangent. I thought tangent.
okay, well, there's another way. So, different ways to go about the same thing. Alright, to remind you guys about trig inverse, again. Woot. Angel, do you remember what the capital letter means on these inverse functions? No? Bella, do you remember what the capital letters mean?
Would it just like for the angle?
Well, that's what the inverse means. Irina, what does the capital letter mean?
I'm not sure, but I thought it meant like you asking at every half.
Not exactly every half.
Does it mean like every single point?
Other way around. Julian?
You're just going for where you're only going for one period, or where the where only each y value has only one.
Okay, it means restricted. I want exactly one answer. So Ivan, what is the one angle that the calculator will return to you when it says, dude, where is sine -1/2? We want exactly one answer. What is your calculator gonna tell you for this one?
Don't know off the top of my head.
Okay, do you know where sine is +1/2? and you tell me how to label that triangle.
Is that a one, 2 square root of 3?
Yeah? Who goes where?
1 short side, 2 hypotenuse, 3 square root of 3.
Okay, what angles are in there? I got the 90-degree in there.
Pi over 6, pi over 3.
Okay, which one's pi over 6, the top or the bottom?
Top.
Okay. If you guys, like, I'll hand back the quizzes tomorrow again. And you need to sit with someone who knows the math to help you do corrections. And it's because some of you are getting a lot of the questions wrong, because you're doing the right process, but you have this triangle wrong. Across from pi over 3 is root 3. Okay, so looking at this, sine, where is sine a half? Is sine adjacent over hypotenuse or opposite over hypotenuse? Opposite. So where is 1 opposite what angle? Pi over 6. So this is gonna be sine inverse, it's gonna be some kind of pi over 6. And William says negative pi over 6. Sine is restricted. When it's capitalized, it's restricted. I only want one answer. I don't want the calculator to be like, some days I'm gonna tell you 11 pi over 6. Some days I'm gonna tell you 23 pi over 6. Tomorrow I'm gonna tell you negative pi over 6. And then the day after that, I'm gonna tell you, something else, negative 11, 13 pi over 6. Like, we want the same frickin' answer every time. Be consistent. So, the capital letter means restrict, and it's gotta be inside that quadrant 4 and quadrant 1 answer. If you're wanting to tell me 11 pi over 6, while it's true that sine of 11 pi over 6 is also negative a half, I want the restricted single answer. Okay? So, looking at this, again, can you guys do those answers still?
Wait, do you know this? No, wait a minute. Yeah, use the restroom.
first one? This card so I can warn the next person.
Like any of those, or?
Yep, anyone you want. Ahmed, can you pick another one to do?
Can I do that?
You wanna pick one? You just do, or you want?
Sure.
Okay, go ahead. You picked him. Isaac, can you pick one that's left? And this person gets the last one, Eleanor. So Isaac, you gotta hurry, so you can pick whichever one you wanna do, so Eleanor gets stuck with the hard one that's last. So Thursday's quiz is still gonna have this trig inverse stuff on it, cause it doesn't go away. All right, so the first one. Cosine inverse, positive angles, positive ratio. Kira, what quadrant is that gonna come out of? Quadrant one. So pi over 3, root 3, 1, 2. Cosine adjacent over hypotenuse. That angle here is pi over 6. However, what is sine of pi over 6? It was a nested thing. So now, I agree the angle was right, but that's not my answer, because I needed to now do sine of pi over 6. What is sine of pi over 6? 1/2. Okay, this one, where is sine 0? Sine values come from quadrant 4 to quadrant 1. Where is sine 0? Right there, 0. Sine is also 0 at 2 pi, negative 2 pi, 6 pi, 20 pi, but I want the smallest one that's inside that range. When is cosine 2? No. Cosine is negative 1 to 1, stuck in that range. Okay. Where is cosine negative angles coming from? Mache, what quadrant?
That's the second and third.
Second and third. Capitalize which one, only one is
Second.
second. So cosine negative ratios come from here. And pi over 3 adjacent over hypotenuse is 1 over 2, not negative root 2 over 2. So this one's not right. What angle makes cosine root 2 over 2? Pi over 4. What is pi over 4 in quadrant 2? So this reference angle is pi over 4. A whole pi. 4 pi over 4 minus 1 pi over 4 is 3 pi over 4. So, guys, still not super strong on these, and it's still on the test. Where is tangent? Ooh. Root 3 over 3, well, where is opposite 1 at pi over 6? We wanted it in quadrant 4, so I agree this one is right, and this one is right. But to tell you what we're going to is this. Algebra. God help us all, algebra. How would I solve this thing here, this side? multiply 1 by 2, ooh, and I meant to say, I meant to have this as 0, I meant to be exactly the same thing. So, that, so I would have had to do something else.
Add the A to each side.
Nope, hi, I
Do
showed you.
another, copy of the interval worksheet.
Maybe. Okay, here. I need to make it one thing times another equals 0. Because if I say A times B equals 0, what do you know about A or B? One of them has to be 0. If I tell you A times B equals 1, what do you know about them? They're reciprocals of each other, that's all you know. But if I tell you they equal 0, either A is 0 or B is 0. So here, either A equals 0 or 2A minus 1 equals 0. So A is either 0 or a half. Here, I would factor sign out. And I would get answers anywhere that sign is 0 or anywhere that sign is a half. And now I need to do the trig inverse and say, oh, maybe I want the infinite number of answers, all of the pi's, 0, pi, 2 pi, 3 pi, 4 pi, on up, negative pi, negative 2 pi, negative 3 pi, all those. I know Emery, the bell's not gonna ring because it doesn't, but the alarm also didn't go off. You guys, hang on, we still have 2 minutes. God help us all. So, pi over 6, and 5 pi over 6, and then full circles of them. All of those would be answered. This is what's coming. Your homework is on Delta Math tonight, please do it.